Om Shri Sai Ram. Today we are going to start heights and distance of basic mathematics. This chapter is actually the application of trigonometry, and this comes under unit 3, the first chapter, which is chapter number 13. After this we have trigonometry. So, as we know that we have aware of trigonometry in the first year of basic mathematics, and today we will start the application of that part, which is heights and distances. Okay, this chapter is the most important practical application of trigonometry. See, for example, to find the heights and distances of visible inaccessible objects like height of the tower, or two ships at sea, and the kite in the air. See, the kite in the air, we can't really put the scale and we can't able to measure what is the distance of the kite which is flying in the sky. So, we can't really able to put a scale and we can't really able to measure it. So, in such a problems we have to use this concept heights and distances with the concepts of angle of elevation and angle of depression. Commonly we are going to use this kind of terms in this chapter, and before we get into the definition of angle of elevation and angle of depression. So, we should well aware of the trigonometric values of which are defined for the standard angles like 0 degree, 30 degree. I will talk about that later, and also we should well aware of this thing trigonometric ratios and some concepts of rectangle, triangle, right angle triangle. So, see, before getting to the definition of angle of elevation and angle of depression, so you should know some trigonometric values . Theta 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. So, this is already you know it. What is now I am going to define sin theta for different angles. Sin 0 will be 0 when theta is 0, sin 30 degree is 1 by 2, sin 45 degree is 1 by root 2, and sin 60 degree is root 3 by 2, and sin 90 degree is 1. Similarly, we can write cos theta. So, you just swipe the values. So, like 1 root 3 by 2, 1 by root 2, and this is 1 by 2, and sin cos 90 degree will be 0, and tan theta which is a slope, you can tan theta is what, sin theta by cos theta by trigonometric ratios, 0 by 1 0, what is this, 1 by 2 divided by what is that, cos theta root 3 by 2. So, what is that, 1 by root 3, and what is tan 45 degree, 1, what is this, root 3, and which is not defined, we can put it as indeterminate, put it as infinity, because the value cannot be defined as 1 by 0, and we should know how to define sin theta, cos theta and tan theta for rectangle, triangle A, B, C. This is hypotenuse side and this is opposite side, I will put it O, and this is adjacent side. So, one shortcut method is there to remember how to define sin theta, cos theta and tan theta for this triangle. This is 90 degree. So, OAO by HHA. See, this stands as sin theta can be defined as opposite by hypotenuse, and cos theta can be defined as adjacent by hypotenuse, tan theta can be defined as opposite by adjacent. Now, we move on to the definition of angle of elevation. The term angle of elevation denotes the angle from the horizontal upward to an object. An observer line of sight would be the above horizontal. See, this is the horizontal and this is an observer, okay, and this is an horizontal line. See, suppose if you noted the object over here, then your sight of eye should be above the horizontal line. Then this becomes what? The angle of elevation. So, similarly, we have angle of depression. See, angle of depression is which is opposite to this one. What is angle of depression? When your sight, eye of sight should be downwards with respect to the horizontal line. So, how that should be is, see, this is a horizontal line, okay, and this is your the sight of eye, and this becomes, okay, the angle of, this is an observer, okay, angle of depression. Now, we will see the example of angle of elevation as well as angle of depression. See, suppose here we have a mountain, okay, and here the person is here, okay. Now, without actually measuring the the height of the tower, we can use the concept of angle of elevation and we can find what is actually the height of the what mountain or a hill, we can say. See this is the observer and it makes an angle of elevation. See, the eyesight of a person is upward and this is an horizontal line. So, this makes the angle of elevation. By using this one, we can find what is actually height of this hill. Similarly, suppose observer is here on the top of a hill, okay. So, similarly, we can make the angle of depression and we can able to find what is the actual height of this hill. See this, how we can find that is, see, this becomes the horizontal, that is the referring line. See, and this becomes the angle of depression, okay. This becomes angle of depression. For this angle of elevation, understand. See, if you write this, this becomes the angle of, see, these two angles are concurrent. The angle of elevation and the angle of depression are concurrent. So, by using this one, we can also find what is the actual height of the hill. This is how we are going to find height of a tower or height of a hill, or if you can find actually the boats at the sea, we can actually able to find what is actually distance without actually measuring it, okay. So, now let us moving on to the problems. The question is, the angle of elevation of the top of a tower at the distance of 500 meters from its foot is 30 degree. Find height of the tower. See, here they have given angle of elevation and they have given the distance between that particular tower to the observer as 500 meters and the angle of elevation is 30 degree. By using this data, we can find what is the actual height of the tower. See, and this can be solved as, first we need to draw the triangle for this particular problem. See, this is a right angled triangle, okay. Here A, B, C, this is 90 degree, okay, and this is the angle. What is the angle of elevation they have given is 30 degree, okay, and this is a tower. I can consider AB as a tower, height of the tower, and this is what actually we are going to find by using angle of elevation. And here this distance they have given as 500 meters, okay. The distance between a foot of the tower to the observer is 500 meters. By using this, we can able to find what is actual height of the tower. So, I will from triangle ABC, I can have AB is what? Height of the tower, and what is BC? This is the distance between what? Tower and the observer. Okay. So, now I can define tan theta, that is tan 30 degree. What is tan 30 degree is, what is tan? Opposite by adjacent. What is opposite here? AB, or you can take H. Okay, I call it as AB as H, that is height of the tower. You can take H divided by adjacent. What is adjacent here? 500 meters. Now, from this table we already defined tan 30 degree. What is tan 30 degree? That is 1 by root 3 equal to H by 500. So, now we want H here. What is H then? H is 500 by root 3. So, this is the what height of the tower. From the textbook they have given different answer. So, do not confuse, both answers are same. What they have did is, they have multiplied 3 and they have divided by 3. What they have done is, 500 into 3 can be written as root 3 into root 3 divided by root 3 into 3. Okay? This get cancel, and H is equal to 500 root 3 divided by 3 meters. This is what they have given in the textbook, and this is what the height of the tower. Therefore, the height of the tower is 500 root 3 by 3 meters. Next, let us moving on to the next problem. So, another problem is very similar to this one. The angle of elevation of top of the chimney at a distance 100 meters from a foot is 30 degree. Find the height of the chimney. How are you going to do that? So, which is very similar to this. See, first we have to draw a right angle triangle according to the given problem. Okay. I will call it ABC, and this is what the angle of elevation, and this is the horizontal line. What they have given, angle of elevation is 30 degree, and what is the height of the chimney? I can call it as H, and the distance from foot is they have given 100 meters. So, now we are going to find what is the height of the chimney. So, from the triangle ABC, I have chosen AB is height of the chimney, and what is BC, which is the distance, okay, which is given. So, now from this I wanted to find this one. So, I can define tan theta, that is tan 30 degree is equal to, what is that? Opposite by adjacent. Opposite is H by 100. So, what is tan 30? So, 1 by root 3 is equal to H by 100. So, what is this? What is H now? H is 100 by root 3 meters. Therefore, what is the height of the chimney? AB is 100 by root 3, or you can write 100 into what is it, 3 by root 3 into 3, and this can be written as root 3 into root 3. So, this get cancelled. Therefore, the height of the chimney will be, AB will be equal to what? 100 into root 3 divided by 3 meters. Let us moving on to the next problem. Here the problem is, we have to find the distance of a ship. Okay. See, this is regarding to angle of depression. See, read the problem. See, the height of a mast head of a ship they have given as 40 meters, and the angle of depression is observed to be 45 degree. By using this data, we have to find the distance from the ship. See, before getting to the problem, we have to draw a diagram over here. I will write the diagram. See, this is the mast head AB, okay, that is the length of the mast head, and here the angle of depression is observed to be 45 degree. See, this is how we are going to represent the angle of depression, that is 45 degree. See, already I told that this becomes angle of elevation, and whatever this angle will be equal to this angle because of concurrent, and this is C. So, now we are going to find, see, this is what the masthead, what is the height of the masthead they have given 40 meters, that is h they have given as 40 meters, okay, and this is what x we are going to find. See, for this we are going to find from the triangle I told you that AB is height of the mast head and BC is distance of ship. Okay. So, now I am going to define tan theta, that is tan 45 degree. What is tan 45 degree? That is opposite. Opposite here is 40 divided by adjacent is x. As you know that 45 degrees, tan 45 degree is 1, which is equal to 40 by x. Now, I want x, x is actually the distance of the ship. So, what is x? X is obviously 40, therefore, the distance of ship is 40 meters. Let us move on to the another problem. Yes, look at this problem. Here, what is the angle of elevation of the sun when length of the shadow of a pole is 1 by root 3. From the last 3 problems, we found out that the length of the tower, length of the ship and all. Now, the problem is we have to find the angle of elevation of the sun when the length of the shadow of a pole is 1 by root 3. Okay, that is what we are going to do it now. So, now the problem is, now let us draw the triangle. See, this is a pole, I will take it as AB as a pole, and we do not know what is the angle of elevation of this one. Let us take it as theta, and this is C. What they have given is the height of the pole is h, okay, and this can be taken as 1 by root 3 times h. So, now let us define tan theta for this. So, what is tan theta? Tan theta is equal to opposite by adjacent. What is opposite side here? H by divided by the adjacent side 1 by root 3 into h. Here h get cancelled. So, what is this? Tan theta is equal to, what about this? If you send it to numerator, it will becomes root 3. See, tan theta is equal to root 3. Tan theta is equal to root 3 when theta is equal to what? 60 degree. So, therefore, this implies that theta is equal to 60 degree. See, what is now? What is the angle of elevation now? That is theta is equal to 60 degree. This is the solution of the given problem. Next problem. See, next fifth problem is, see here also we have to find the angle of elevation of a tower. See, what they have given is that they have given shadow of a tower is 75 meters height, and they have given the foot of that one is 25 times root 3 meters long. That is what the shadow they have given, length of the shadow. For this, I am going to write the triangle, right angle triangle. Okay. See, I will take it as AB, that is the height of the pole, and this is C, and this is what the angle of elevation, that is what we need to find. What is the height they have given is 75 meters, and the length of the shadow they have given as 25 times root 3. So, now for this same thing you repeat what we have did in the last problem. So, you define what is tan theta here. Tan theta is, what is tan theta? Opposite by adjacent. What is opposite here? 75 divided by 25 root 3. So, now what is this? Tan theta is equal to, so what is this? 25 ones are, and what is this? 25 5 5s are, okay, 5 ones are, 5 5s are, 5 ones are, 5 3s are, okay. So, what you have got it? 3 by root 3, okay. So, now tan theta is equal to 3 can be written as root 3 into root 3 divided by root 3. Here one of the root 3 get cancelled and we left with tan theta is equal to root 3. So, now what tan theta is equal to root 3 when tan theta is equal to root 3 when theta is equal to 60 degree. Therefore, theta is equal to 60 degree. Therefore, what is the angle? Thus, the angle of elevation is 60 degrees. Next problem. See, the problem is here we have to find the length of the ladder which is which is leaning against the wall, it making angle of elevation, that is angle of elevation what they have given in the problem 60 degree with the ground, and the distance between wall and foot of the ladder they have given as 36 meter. By using this data we have to find the length of the ladder. See, before that I will write the right angle triangle. For this I will take AB as what? Wall. I will take AB as length of the wall, and AC I will take it as what? The ladder, okay, the length of the ladder, and here the angle of elevation they have given which is 30 degree, and the distance between the foot of the ladder and the wall they have given as 36 meters. Okay. Now, I wanted to find this one, okay, that is hypotenuse side of this triangle. Okay. So, that for that I am going to define cos instead of tan. For tan what they are going to have it is we can, that is opposite side and adjacent side. We are here that is not required. See, I want hypotenuse side with the adjacent side. With this we have adjacent side and hypotenuse side as for cos, not for even for sin also, because for sin we have opposite, for tan also we have opposite we do not have anything. So, with only adjacent and hypotenuse with the angle of elevation we are going to find, that is why I am taking cos. So, here I can define cos theta, that is cos 30 degree, that is angle of elevation. What is cos? That is adjacent by hypotenuse. What is adjacent here? That is 36 divided by hypotenuse. Hypotenuse simply I will take it as AC, that AC represents the length of the ladder. So, what is cos 30 degree? Cos 30 degree is root 3 by 2, which is equal to 36 divided by AC. Now, I want AC from here, you do cross multiplication, root 3 into AC is equal to 36 times 2, and what is this? I want AC, what is 36 times 2 is 72 divided by root 3. This is what the length of the ladder, which is 72 divided by root 3 meters. Here which is actually related to the second problem which we have solved just before starting of the problem. See, here the height of a mast head of a ship is 50 meters and the angle of depression is observed to be 30 degree, and we have to find the distance of the ship. See here, this is angle of depression. Okay, see, this becomes angle of depression. See, whatever this with reference to the horizontal line, we observe to be that 30 degree, and this becomes angle of elevation with respect to that. So now it is 30 degree. For this, I am going to define tan 30 degree, which is equal to, what is tan 30 degree? Opposite by adjacent. What is opposite here? That is 50 meters divided by x. That is what we actually find the distance of the ship. So now what is tan 30 degree? Tan 30 degree is 1 by root 3 is equal to 50 by x. Now what is x? You do cross multiplication. X equal to 50 into root 3, or else you can write down x is equal to 50 into root 3, 3 divided by 3. X is equal to what? 50 into root 3 into root 3 divided by okay, you can stop at this stage, no problem. 50 into root 3. So, this is the what? The distance of the ship. Therefore, the distance of the ship is what? 50 into root 3 meters. In the next session, we are going to solve 4 and 5 mark questions. Till then, Sairam.